Let me save this to 04. So we add 2 perimeter in this 03 and make this, you can look at this way. So make that is randomly in this diagram, a diameter. Use this scale SF. SF is calculated by the scaling plus this S variance, and this Z is based on the variance of the random number. So our tree currently nothing more than a single branch. That is the main branch. To change this, we need to fork at least one branch at some point during our simulated growth process to prevent us from branch infinitely often. We need to introduce another recursion depth variable, branch depth, so we don't have infinite number of the branch. So now let's starting. So after S variance, we will have H min MD initial, that also are new variance. So MD initial and min depth, run seed, scaling, S variance, and then we have this BD initial, branch depth, branch angle. So as usual, we don't have those perimeter code, so we need to give them the number. So here is MD initial is 20, this 20, 42, 0.97, 0.1, and the BD initial is 1, branch depth is 1, branch angle. We use 30. Later we can see we change to 45, change to 60, and that's fine. So we got some error in starting from file Recursive line 18. So here as SF as FC all in the line 18, or 17, 23, min depth, and here we have this min depth. Do we have any typo? Not yet. Yeah, let's continue. So because we don't have any additional code to use that, we just putting those numbers, and we have our line extruding. So now this is the scale SF children. So we're starting from this, and we start if this min depth more than 10. So it's here. So this one is still kept as variance. So let's see our tree. So we should have H increment, MD initial, min depth, no change, Z, no change, scaling, S variance, and we continue add those new perimeter, branch, depth, branch, angle, and then, so here, and we have adding the needed, the new, the perimeter, even we don't have additional code. Now we should analyze this one. So after we have this line extrude, this is called this should we branch. Let me continue. So we have whether we branch. So we should have a if yes, then we will do those numbers of the things. So we go to this part. So condition, we will put here, and then we will have our the main parts. So what is our condition? So if branch, we need to ensure we will have the finite the branch depths. So if that is more than 10 at 0, and the second condition is stay 0, 0.8 to less than MB. Now we have this new parameter mean branch, mean depth. So that is our condition. We have nothing to do. So if we do this branch, we have the branch based on these two conditions. So our branch depth is here. Branch depth is 1, so it's more than 10, and this whether is can fulfill this condition. If fulfill, let's see, we have R angle defined is equal to this Z. So they is our function from 2. So they are using the random number. So whenever we use that, we get our random number. Zero, 7, 2. That is our, and this index is a random value index. So random value is here. So index. So we gave this one because the random value is just from 0 to 1, gave a 10 result. And what we point this 3 is the random seed. So that is the thing we will get our 10 number random number between 0 and 722. And based on the random seed is 3. So that is the angle. So that means is you can have two double 360, and you get this random number. So that is our first. And then branch angle is equal to branch angle, make that random, plus our Z is from 0 to 0.5, and then you have seed as 4 times branch angle. So we have defined these two variables. Now what we will do is we will draw the tree. So let's copy this and change scale. So this is our tree. If we don't have any the translate, so let's see, we need to have our tree with each increment MD and mean depth. So this we don't need that change. So mean depth, and Z is from 0 to from 1 to 10, 100, but we have seed is 5, and the scaling as variance. Well, so what the next latest one we have is number 4. It's interesting. It's just closed without any warning. Let's double check is what's the issue. Oh, so possible. Let's do editing here. So it's possible I don't have those translate the correct perimeter. That is your plan B. So if you don't have that, so now we have if here, let's double check. We don't have this branch depth -1, so that's the big issue. So let's now open, because we create our infinitive this running. So I hope now they are response. Okay, good. So that is the very this important things. So let me try to make this transparent. Then what I got, yeah, it's the same. So I suppose this is we need to do the rotate. So now we just have our tree, the branch. So let's double check our perimeter. Correct. And then we first gave our rotate based on BR angle 0, 0. Yeah, should have our close bracket. So let's see, we got 1, 2, 3, several branch like this one. That's the rotate. First rotate, then we will rotate second. So every time is you will rotate by some random. So that can make that distributed. Our angle. Let's see. You can see here. Now they make it more random. If I change this as another, like I change to 5, you will get a different one. So 5 is looks better. If we see 3, is here. This side is don't have any branch. So translate 0, 0 H increment. Let's see. So they just get higher, but I like make this into 5, or maybe let's see 4, 6. You can keep checking, but I just wanted to get some nice distributed. Maybe I just use this number 9. So that use run C. Is 9 instead of 3. So that is my parts. So now we got this branch. I think it's all the other we are keep seeing the same. Do we need to change any others? Linear 0. You see here is 7. So if I got this, let me see here. Okay, 7, 2, 1, 2, 3, 4, 5, 6, 7. So here we got 7 branch. Let me see the branch depth. What's our branch number? branch angle. How many branch? Which parameter control that? Because it's the angle. It's a branch depth. Branch depth. That's the 1. How this branch number? The random value from 0 is equals Sn, the current branch. So as here you can see from figure 10.2, the number of the branch is controlled by branch depths 1, 2, 3. So I change from 1 to 2 is getting this one, and if I change that to 3, that means the depth is you have first get our level 1, and depth 2 is you keep adding the branch, and if I put that to 10, then I think it's we'll have a very busy branch. You can see here that is nice, but it's a very busy tree. So let's put that to 3, and I put this. I remember 5 is nice. It's busy enough, so I use 5 as the seed. So that's our branch for now. Let me save and make that to another file. And our branch seem a bit unrealistically long at the moment, and they do kind of peel up unnaturally depending on our on chance change. Let's address the first problem by assuming that the height increments should decrease as the recursion depth increase. So it should be changed. So when we have the depth and this, we should change this height increment. We can make this possible where another parameter we will add R increment. We only have H increments. Now we add this X1 R increment. And we have the others. Let me double check. Rand scaling as BD. So in the bottom, we should have here we add this R increment equal to 0.7, and also A for mean depth, we also need this R increment. Others are the same, and for this tree we also need R increment. And we need to define this one. So we have this calculation here. What's the R increment? That will equal to H increment minus H increment divided by 2.5 times we are using our power, the function, so R increment powered by branch depths. So when we have those depths is increased, then we will decrease this age increment. Shall we get this difference? And we have 1, 2, this decrease. So if we don't have this R increments, I don't see the difference for now. So we need to use these R increments. This R increment is only inputting here, but do we have any change on the data from here? Power, tabs, branch depth is defined by here. So we have this one, but to me it's not create difference. Circle, we have R increment is 0.7. Let's change this. R increment. Oh, here is we should not define this. We should use a new increment. That's the parameter we should use. So this age will be replaced by the new increment. But in this mean part, it's still the age increment. Now you can see here, so it's getting the shorter if we have that, because we have a new increment with some decrease of the based on the scale. Okay, thank you for watching till now. We have our base tree with 3 levels branch. We will continue to next for more detail the structures. See you in next video.